Here's a solution for day 2, problem 1. Given function f and function g, find the following. First, we're looking for f plus g of x. This can be interpreted to mean taking f of x and adding g of x. F of x is the expression 2x plus 3. And to that expression, let's add g of x. G of x is the expression x minus 2. And so this adding of functions problem really means to take 2x plus 3 and add x minus 2. 2x plus x is 3x, and 3 plus a negative 2 is a positive 1. So we get the answer 3x plus 1. Question B, f times g of x. This can be interpreted to mean f of x times g of x. F of x is the expression 2x plus 3. And g of x is the expression x minus 2. So f of x times g of x means to go 2x plus 3 times x minus 2. We can do this using FOIL. 2x times x is 2x squared. The outer product, 2x times negative 2, is negative 4x. Now the inner product, 3 times x is positive 3x. And then the last terms, 3 times negative 2 is negative 6. These x terms can be combined together. So the final result is 2x squared minus x minus 6. Question C. We want to do the composition of function f and g. In algebra class, you would have seen it like this. Find f of g of x, where you're taking g of x and substituting it into function f. Go back up and look at what function f is and what function g is. This composition means to take function g, which is that expression, and input it into the variable for function f. So we want to go 2 times, and then in place of the variable, fill in x minus 2. And then comes the plus 3. Let's simplify this. 2 times x is 2x. 2 times negative 2 is negative 4. And negative 4 plus 3 is a negative 1. So the answer for this composition of functions is 2x minus 1. Now day 2, problem 2. Solve the quadratic equation using completing the square. So here we have an equation. On the right side there's 0. On the left side is this trinomial, but this is not a perfect square trinomial. When this is factored, it doesn't create a binomial squared. So we want to rewrite this trinomial so that it is a perfect square trinomial. Here's the technique. First step, subtract the constant term to the other side. That creates this equation. Notice the blank spot in this position. To figure out what number to put in here, we're going to look at the coefficient of x. Take half of that number, that makes 4, and then square the 4. 4 squared is 16. That's the number that we want to add into this position, plus 16. If you add 16 to the left side of an equation, you have to add 16 to the right side of the equation. Now the reason for putting a 16 here is so that this trinomial is a perfect square trinomial. Perfect square trinomials factor into a binomial squared pattern. There's going to be two things inside here. First of all, this is going to be an x. because x squared is this x squared. And then this part here is going to be positive 4. That same thing that we got when we had figured out half of 8 was 4. X plus 4 squared is equal to x squared plus 8x plus 16. If you don't believe that, you can expand this out using FOIL. X plus 4 times x plus 4, and work that out. It makes that trinomial. This is equal to, and on the right side of the equation, negative 5 plus 16 is 11. So we've taken the original equation that had a trinomial in it and rewrote it as this equation, where on the left side of the equals, there is a binomial squared. The reason for doing that is so that we can now use square roots to get us the answer. So the square root of the left side makes x plus 4. On the right side, take the positive and negative square root of 11. Final step, subtract 4 from both sides to get the x alone. We have negative 4 plus or minus the square root of 11. This actually is 2 answers if you were to work this out. To get the first answer, you'd go negative 4 plus the square root of 11. Press equals on the calculator and you'd have an answer. And to get the other answer, you'd go negative 4 minus the square root of 11 on a calculator.